find the least common
over
multiple
36.
of an algebraic
And finally,
expression, now that I
we'll
have
use
the
a
same
similar
denominator,
strategy.
I can
We'll
add
take
these
our
fractions
expression,
together.
say 18
15 plus
x to the
21 is
third
going to be
y squared, and break this
36
down into its prime factorization.
over 36.
This is 18 times
and that's equal
x
to
to
1.
the third.
So that's how you
y
add
squared.
two fractions.
And then this
It's
is
real
going to be
complicated, right? It's
2
been a
times
while since we
9, so
really
3
thought
times
about
3,
how much goes into
which
adding
means this is
fractions.
2 times
But we really
3
need to
times
break this
3
down
times.
and find
This will break into
the
x to the third
greatest
y squared.
least common multiple. So
I'll have 3 x's, x times
when we're
x,
dealing with algebraic
and
expressions,
2
we
y's.
need to do the same thing. The least common multiple
12
will be
x to the fifth y
an
break
expression
down
which is
into
divisible
12
by both
and x
of
to
the
the
two
fifth
expressions for
y,
which it is the least
and then
common
we have
multiple
2
of.
times 6
And we'll use the same approach. We'll
2
use the
times 3
prime factorization
3x
approach
to
to
the fifth
figure out how to
y.
do this. So in this
We can
situation,
write that out. So it'll be 2 times 2 times 3,
I have
then 5 x's
18x
times
to the
1
third
y.
Now in
to the
prime
third.
you don't need to
If I
write
break
down
this
the
into
full prime
factors, I get
factorization here.
18,
You just need to know what's
and
happening.
x to the third, y
So,
to the third.
to find the least common multiple, you
This
start with
is
1 and then figure out what you're missing. So I'll start with the first
2
one.
times
2
9
times
which
3
is 3
times 3
times x
and
times
here I have
x times
x
x
to the
times
third times y to the
times
third.
y.
This breaks down into
x
and I
times
figure
x
out what I'm
squared,
missing.
then
Well,
x
what have I
times
already
x.
used? So for every
Same
one
thing
of
over
these,
here,
I can cross
y
out
times
a
y
maximum
squared,
of those.
and y
There's a 2
times
y.
Here's
In
a
other words,
3,
this is going to be 2 times
here's
3
an x
times 3 times
here's an
x.
x. Here's an
times
x, so 3
x
x's, x,
and 1
y.
Those ones I get for free. And then
Times y.
what don't
times
I have
times
over
y.
here? I'm missing a 2, so I need a times 2.
Now
Now in practice we wouldn't actually break
That's
this down
this one, and then I'm missing
into its prime
2
factors,
x's
but you'll get
here,
the
this
idea.
x and this x.
This
So
one breaks
x
down
times x
into 12.
and x to the fifth.
So this would
y.
be equal to 2
breaks down
times
to
2,
2
which is
times 6,
4 times 3
2
times 3. That's
This is
36.
x to the fifth.
How many x's do I
times
have? 1, 2, 3,
y.
4, 5. And you'll see this breaks
X
down
to
into
the 5
5
x's.
then y
So this will
squared.
be-
The least common multiple between these two
I'll just save
is
some time
36 x to the fifth
2
y
times
squared.
2 times 3 times 5 x's. And
In order to find the least common multiple, you need to factor. You need to find the least common
factors
multiple. So we're going to have to factor expressions. You can start with one of them.
I'll
and
factor
see what's
this
missing.
expression.
So, and we can start
this
with
expression
2
and see what the
times
factors are.
3, and
times
you
3
want to put those
times
factors
x to
together.
the third,
Any factor that appears
y
in
to the
both, you
third.
can use 1 for.
so
and then anything left over, you need to
each
add.
one we use here,
So
we
let's
can
see
cancel
what
one out of the
other. So here I have a 2.
I can get rid of
The
one of the
yellow
twos.
term factors in 2. This is 3
Here's a
x
3
squared
and get
plus
rid of
15.
3.
Step 0 in factoring is always to factor out the greatest common factor. What do
I
they
have
both
x
have in
to
common?
the
They both have a
third,
3
So I can get rid of 1, 2,
and an
3
x.
x's.
So this is a
and I
3x
have
y
comes out
to the
as a
third.
factor. So I can get rid
What's
of one
left over
of these to get rid
is
of
a
one of
single
these
x.
x.
So what I'm missing
plus
is
5
a 2. So the 3 factors
here.
of this
and
first
then
expression
2 x's.
are 3, x, and x plus 5. Those are the things that are being multiplied together to get 3x squared plus 5x. The green one here, well, step 0 is always to factor out what they have in common. Looks like all 3 of these are divisible by 6, so they have a 6. This is going to be 2 times 2 times 3 times 3. This leaves
That's
36
squared.
here. Then
6 times
x
what
to the 5th is 24.
y
That's going to
the
be 4
squared. So this will be plus 4 times x.
And then 6 times what is negative 30? That's going to be negative 5. And the x squared we keep. We have to keep factoring. So this first part seems factored well enough. But the second part here, there are 3 terms, 1, 2, 3. So we can use the headless man. 2 numbers that multiply to negative 5 that add up to 4. So we want 2 numbers that multiply to negative 5 that add up to 4. One of them will be negative, one of them will be positive. It seems like 5 and 1 will fit the bill. And you want the bigger one to be positive. And so that is the factorization of that trinomial there. Now I have 1, 2, 3, 4, 5 factors if you count the x's separately. And so to find the least common multiple, what you need to do is figure out what's missing from the 1. So you can start with one of them. I'll start with the yellow one. I have 3x times x plus 5. Here's my least common multiple. I started with this, and then everything that's in there I don't have to use. So this is a 3, so there's a 3 in here. So if I use that 3, there'll be a 2 left over. There's the 3 times 2, so I'm using up the 3, leaving a 2. I have an x here, so one of these x's I'll get rid of. And an x plus 5 is here, so I can cross that guy out. So what's left over in green here is a 2, 1x, and an x minus 1. So all the factors that are here that I haven't already gotten from here. And so I can make this a little bit nicer. 2 times 3 is 6. Then I have 1x here and 1x here, so it'll be x squared times x plus 5 times x minus 1. That's the least common multiple. You can multiply that out further, but it's acceptable to stop there. Okay. Let's find the least common multiple between this expression and this expression. Well, first thing we have to do is factor. The blue expression factors. I need two numbers that multiply to negative 40 that add up to negative 3. You can work that for a minute to try to figure that out. One of them will be negative and one of them will be positive because they multiply to a negative number. The bigger one will be negative because they add up to a negative. They need to be 3 apart. So 5 and 8 seem like a good pick. If I have a negative 8 here and a positive 5. So the blue expression factors into x plus 5, x minus 8. The green one, I need two numbers that multiply to negative 8 that add up to negative 7. Here, 8 and 1 seem like the options, and the bigger one's negative. So to find the least common multiple, I start with one of them, x plus 5 times x minus 8. And I see that I've already used an x minus 8, so I don't need that one. So what's missing is an x plus 1. So this is the least common multiple. The first expression divides this part, and the second expression divides this part. Okay, let's find the least common multiple here. You got two numbers that multiply to 9 that add up to negative 6. Seems like negative 3 and negative 3 fit the bill here. And here we have two numbers that multiply to negative 21 that add up to negative 4 or to positive 4. Seems like 7 and 3 are good picks, where the bigger one is positive. To find the least common multiple, I need to start with one of them. So in this case, x minus 3 times x minus 3. I used an x minus 3 here, so I can cancel this one out, and I need the x plus 7 to get the least common multiple. This is the least common multiple. Let's try that again. Factor this, factor this. Here, I have 2x squared minus 4x. I'm going to do the greatest common factor here. It looks like there's a 2 and an x, so it's 2x. What's left over is an x minus 2. And the green one here, it looks like a 4 comes out. What's left over is x squared minus 4. I'm not done. This is the difference of squares. I can continue to factor. So I'll factor that 4 and 2 times 2. And this into the difference of squares, x plus 2, x minus 2. So now I find the least common multiple. I start with 1, 2 times x minus 2, and see what I'm missing. I have a 2, and I have a x minus 2, which is here. What's left is a 2 and an x plus 2. I can combine the 2's together at least and get 4x times x minus 2, x plus 2.